Now when we do look at this Kronos library, right, the Kronos library basically implements things like DAL services. The DAL services is basically a way to separate out different schemas and their implementations into groups. Because not every module needs to load every DAL service. Like for example, if you write more modules here which process this data, more parts of the code, then they don't need to load, like for example, event data is looked up by one module. You use the event DAL service, and that thing supports methods like store event, load event, count events, whatever sort of thing you keep adding.
What is the acronym DAL?
Data access layer.
Data.
Standard database terminology sort of a thing. You have a data access layer, and Kronos is sort of the DAL, but the way Kronos exposes itself through a multiple DALs as this thing, as opposed to one data access layer interface. So you can just say read write data, right? But you have different schemas, different types and everything. So the way we try to implement the Kronos interfaces, each of these DAL services, is it takes a proto. It takes a proto for the write interface. So the idea is that whenever on Skygate we get a proto, we just hand it off to Kronos saying, okay, go serialize this proto into the database. So the Skygate doesn't know anything about schema and all these sort of different things. Skygate sort of only mostly knows about what to do, which account, where should I send it type of a thing. But the actual, how the data is transformed into a schema and stored is all within Kronos. That's what is the data access layer, typical splitting. Now the idea in future obviously is that when you're doing this reads and writing, we have to place the cache somewhere. Kronos is a good place to place the cache because everybody uses the Kronos library. This is where you can also say, oh, load this stats or load this inventory. You can also say, oh, put it in Redis and make this guy the owner of the cache, because once you have a cache, you have to figure out how to invalidate it, which means all the writes have to invalidate it, right? So in a library, Kronos library is where we'll most probably put the Redis cache in there. Does it clarify most of the data flow part of it? So now one additional part.
Redis is only used for caching.
Right now it's only used for session caching, it's not used for any other caching. For example, when we create a session, we just store the session caching, session state and timeout and everything in there.
This session is basically the
user login sessions. I'll tell you one more thing. The user login is a little bit interesting. So one other thing this guy does, like we said, right, it talks to Kronos. There's one more part it actually uses, which is to go through the Sky Commander to OpenStack. So what we do is in the SkyMap UI backend, we don't replicate every information from OpenStack into our database. We replicate some information, like list of VMs and all these things and their state. Some of that is replicated, but not all the information. One basic information we don't replicate is usernames and logins. So when an account, there is a username and login that's required, we actually route it all the way to the OpenStack of that machine, get it authenticated, get a token, and store the token as the session cache in this thing. So as the user is continuing to do more OpenStack operations, the token is used to sort of go back and actually send commands to it. Right. So every command you actually send the session token.
So you just make an OpenStack request using that token?
Yeah. Right? So it's sort of you construct an OpenStack request and then send it out. And the way we do it is SkyMap, there's protocols which are defined, which was called zero stack commands and OpenStack commands. Okay? And the way these are implemented is whenever SkyMap wants to do one, SkyMap gets a UI, a URL, right? Let's dig deeper into that part of it, what the SkyMap does. There's a couple of approaches to doing it. We picked one for now, but we are already contemplating how do we map this thing. So what do you have to do when you get a command from a UI, right? You basically get console. Console is the UI. API is what the UI talks. API.zerostack.com / so whenever we want to execute, customer wants to send a command and he's logged in, the UI wants to send a backend command, right? There's two ways to do it. One is you actually make it a customer.api.zerostack.com That way you already get from the subdomain, you figure out which customer's request it is. What we do is we actually embed right now the customer ID in the header. So the customer ID actually comes as part of the headers. I mean, which basically maps to what we call as account ID. Okay? Then in this one, we basically, the way we constructed is we try to mimic the way the OpenStack API is structured. So you'll say something like, Nova / I think V1 / servers and the post or get or something, right? So this fragment looks very similar to what an OpenStack fragment looks after the domain. So now what SkyMap does is it extracts different parts of the thing. It knows what is the account ID, it knows what is the fragment. Then what it does is, it takes this request, looks up a Skygate, this thing is mapped to a Sky Commander / Skygate. Okay? So we map this to the Sky Commander Skygate by looking up Skybridge, and then we send the command to the appropriate Skygate. And what we do in that command is we put this thing which says, okay, which service are we looking for? Nova. What is the fragment? Is /v1 / servers, this thing. And the method, obviously, method is post or whatever, right? So this is what we construct. This is what an OpenStack command looks like.
So it should have a token ID as well.
Yeah, tokens. Actually, the token, the good part of it actually is, the token gets embedded. This is one part of it, which is the meta information. Then there's an actual command.
Mm-hmm.
In OpenStack commands, you're actually supposed to supply the token ID in the command itself,
Yeah.
right? So as part of this command itself, like the token is somewhere embedded here.
What is the
Dot
significance of token?
Token is authentication token. So every command, you don't send user ID, username, password. You log in once and then you get a token ID, and the token ID is valid for doing commands for some amount of time till the expiry.
This is all HTTPS, right?
It has to be.
Yeah. No, what do you mean by
So this is all.
no, the token ID is a keystone token ID.
No, but
No,
it-
that's fine. But the actual request that goes out to OpenStack, it is an SSL.
So wait, no, this is the OpenStack command. This is the structure, right? How does it get to the other side? Is what we do is we use the command mechanism, right?
Okay.
So we take this OpenStack command, we call it a protobuf, which is a OpenStack command protobuf.
Put it in a.
Marshal all of this OpenStack command into the body, together with the proto header, which says this is an OpenStack command, and wrap it in our command proto and send it.
Sure.
So now, effectively, when this guy receives a command, right, as a response to the poll, right, we said there's a poll and then the command comes back. Inside this command, it says type equal to OpenStack command,
Sure.
and then it has, bytes, right? What we do is whenever this comes down, we take this OpenStack command. This is an OpenStack command. No, the star commander. Sorry, this is a Skygate. This gets routed to the star commander, and that's where this happens. Okay.
That's where it will talk to the local OpenStack.
So what this
API.
does is, this basically looks at it and says, this is an OpenStack command. And by the way, what is the service? Nova.
Okay.
So first thing it does is, it does a
Service
get
number.
service
Okay.
call to StarNet. Because StarNet knows where Nova is running.
Okay.
That's the owner of this thing. And this responds back with where is the service location. And then it actually does an actual OpenStack API call.
The actual
to Nova.
OpenStack API call happens in the cluster itself.
In Star Commander, yes.
Okay.
Yep. So we don't tunnel everything out through like that. I mean, we're tunneling it. We're not directly doing the calls directly to open. Otherwise, you're going to expose that on the public internet, right?
Mm-hmm.
So we basically are wrapping all of this up, routing it to the appropriate location here.
Yeah.
And then when this response comes back, you get a response back, you marshal it, and then it comes back here, he opens it up.
Okay.
And then that sends the response back to the UI.
So Kiran, I have a question here.
Mhm.
So there are a lot of components involved in this whole process,
Yeah.
starting from UI,
Yep.
front end,
Yep.
to going to the OpenStack and running.
Mhm.
Now, what if a given node
Mhm.
fails
Mhm.
in between
Mhm.
when it was in the process of handling a request? So where does the persistence come into the picture? And
There is no
who decides-
persistence.
Okay.
So there is a retry. User has to retry. So one thing that happens is we have to start building in more of this.
Mhm.
For example, even in any guy here could crash after he's taken the command, right? Things restart. What the UI will see is an error. You will just see an error saying, oh, command failed to execute. But the same thing, imagine if you had the actual OpenStack GUI, any network service, you'll have the same problem. That you start something and then you try to send the request in the HTTP somewhere, you don't know whether it got sent or whether it got cut off. So one reason we don't retry, okay, is because of post. Because when you're creating resources, you can't just retry the request if the other side doesn't respond.
So,
Because you'll create one more request or something like that, right?
So
one
that
more
is-
resource.
so that is acceptable if the end service was not running, right? But what if an intermediate guy was...
So that's the thing. So you don't know where do we do the retry, right? That's the thing. If some guy crashed in the middle, where do you do the retry? So now, I mean, over time, we can start building more sophistication into it.
Okay.
But as of now, the nice thing is UI driven, which means there's a user trying to do something in front of it, either in the script or in the user, right? So it basically says, it gives you a feedback saying, hey, it failed. So user can retry, right? So one thing we we started adding more resiliency obviously over time, right? So the first thing we added was here with the Sky map, right? If it's trying to look up a Sky commander, it gets a Sky commander and then it sends a request to it and that guy doesn't respond, right? Then it tries to look up the Sky commander again. Okay? Because the idea is that when you have a cluster of these things, if you're not even able to talk to somebody to send the command, right? If a connection even fails, then you can definitely retry. But once you've posted it, then you have to be a lot more careful about reposting that stuff.
You should
automatically.
not, but every process can maintain a write-ahead log to
Right.
do that, right?
Yeah.
Like, so you posted to Sky Commander responded, Sky Commander died. It comes back, it looks at the log, it knows what it has to replay, and it should in
Yeah, but that's what I'm saying. So let's say this post actually went in
Okay,
to OpenStack
okay,
and it got created.
okay.
You wanted to create a VM, that VM actually got created, sort of a thing.
Okay, then it didn't.
Now somewhere in the thing, everybody died. Everybody came back up.
Okay.
Everybody will start restarting, then there's a flood of retries, right?
No, that's not true, right? Because as soon as you sent out that request, you had a write-ahead log to say, I'm sending this request, sent it, and you won't have a response to say act. So it will know what action to take after that. When it comes back up, it will act back rather than everybody.
Yeah, so that's the thing. So we have to build in a design where it's not simply replay. You basically have to say, I have to tag each one with an ID.
Correct.
And then you have to check before you replay it.
Exactly.
When your act comes back, you have to do the full Aries scheme.
Yeah.
Right? So you have to do the full write-ahead log scheme where everything is rolled back, rolled forward and all that stuff. So as of now, because the reason is, this is not data as much as user-driven actions.
Sure.
Right? So for the user-driven actions, we left it more as, okay, user will retry if something fails.
But
Over time, we can analyze where are the failures and try to put the right-hand log in the right place.
But the problem with this is, say somebody is building an Elastic service, something like they're trying to run Hadoop, which will bring up new workers as necessary, which will mean that it will make Nova calls to do that, and destroy them when they are done. If any of these things fail, you cannot expect user feedback to go through.
I mean, scripted, right? You're basically saying
Yeah.
anything scripted.
Yeah.
Right? Not just Elastic, even if it's scripted to bring up a cluster,
Right.
the script fails in the middle. What does it mean?
Yeah.
Right? Yeah. I mean, that's the thing. Over time, we have to build in more recovery of different parts of it. As of now, wherever it's like sort of harmless to retry, because we know it didn't even get to the other side,
Sure.
we do the retries there. Otherwise, we haven't done the rest of the full scheme yet in terms of saying, okay, let's make it really resilient to sending this command. Because we basically it's still like a very script or user, it's still driven thing as opposed to it's not data blocks they're sending. They're really control plane actions, right?
Okay.
So we'll figure out where is the thing that, so one of the first thing, like I said, we added is, hey, the Sky Commander discovery, sometimes it tells there is a Sky Commander, meanwhile something died or something timed out and it's not reaching the other side. Okay, let's look up for the Sky Commander again.
Okay. I have two questions now.
Mhm.
So first thing is that when the request comes,
Mhm.
based on the account ID, we do a lookup to get the Sky Commander.
Mhm.
What is the value in it? It is the IP of the Sky Command?
Yeah.
IP address.
Yeah, IP colon port, yeah.
IP protocol. Okay. Second question is, say when the Sky map actually talks to OpenStack to get the token for authentication from Keystone. So if that times out in the middle because the user is actually taking long time to do
Yeah.
something, does the Sky map know that and then again initiate a
So what do you mean
authentication?
user is taking a long time to do something?
Say he created a VM
Mhm.
and then somehow the actually OpenStack token expired.
Oh yeah, so we do have I think we do have a reauth thing in the thing. I'm trying to remember how we do the refresh. Because again, username, password is everything, right? Which we don't store.
Yeah.
So I think as of now we don't. So we talked about this, but we haven't really resolved the thing. I think we basically just show it as a session timed out, and the user sort of gets logged out and he has to relog in. I mean, this is standard, right? You mean try something, it's like a long running operation. You try to go back, it says, oh, session timed out, please log in again. Yeah. The thing though is one thing here which we are trying to abstract stuff out is the usage of OS client. So we're writing a module called OS client.
So Sky Commander can keep a copy of it and issue it.
Yeah, no, I mean in general, abstract all of this OpenStack sort of thing handling from different processes into a client module. And the idea is that this is a client module which sort of knows about services and command and response sort of a thing, which is a Go interface to an OpenStack REST service. So this we can actually, our plan is it doesn't have anything with respect to our specific implementation. There is no Go-based OpenStack client. So this is basically that Go-based OpenStack REST API client. And we can open source this at some time also so people can add more to it. Right now we only added some Keystone functions, some Nova functions, whatever we sort of like. And all this is doing really is, there's a type which describes what is the request, so you can serialize it to JSON and send it. There's a type which describes the response, so you can deserialize it and hand it off to whoever